For nearly half a century, Voyager 1 has been drifting farther and farther from Earth, a silent emissary from the 20th century now wandering the unknown. But in April, after months of eerie silence, something happened, something no one at NASA expected. A new transmission arrived. Not just static or noise, this was data, clear, powerful, and impossible. Voyager 1, now over 15 billion miles from home, had finally pierced through the outer veil of the solar system and emerged on the other side. But what it found there, it wasn't a cold, empty void. It wasn't nothingness. It was structured. It was alive. It was something that forced scientists to question everything we thought we knew about the galaxy. The protective bubble we call the heliosphere. It's not a boundary, it's a barrier. And beyond it lies a realm of twisted magnetism, whispering plasma, and violent radiation storms. What Voyager just uncovered is changing the way we map the cosmos. And if what it's transmitting is real, then we've been living inside a cosmic illusion, shielded from the true nature of the universe. After an extended blackout, NASA had all but accepted that Voyager 1, our most distant spacecraft, might be gone forever. The signals that returned were jumbled, corrupted, and unreadable. Engineers traced the issue to a cosmic ray strike that had likely damaged its internal memory. But miraculously, through a series of remote software reroutes, essentially digital CPR across 15 billion miles, NASA revived the spacecraft. Slowly, instruments came back online, and what they revealed stunned even the most seasoned astrophysicists. Voyager had not only survived its crossing into interstellar space, it had begun detecting structures, clear regions with shifting plasma densities, sharp changes in magnetic field orientation, and subtle pressure waves traveling across unimaginable distances. These weren't just background noise, they were signs of order. Voyager had entered a domain where ancient forces still shaped the present, where the interstellar medium behaved more like a turbulent ocean than the featureless void science had long imagined. The sun's protective shield, once thought to gently transition into space, had a jagged edge, a line in the dark, and Voyager had crossed it. One of the most surprising revelations came from Voyager's magnetometer, which detected an interstellar magnetic field tilted at an angle that contradicted every prediction. It wasn't supposed to be like this. While scientists expected some deviation between the solar and interstellar fields, the angle was far too sharp, suggesting not a transition, but a confrontation. What Voyager might have discovered is a magnetic turbulence zone, where galactic magnetic lines twist and reconnect in a chaotic dance. These are not minor deviations. They are vast, invisible structures that could define how matter moves through the Milky Way. The implications are staggering. Magnetic reconnection in these regions could be responsible for accelerating cosmic rays to near-light speed. It could influence how stars are born, how supernova remnants evolve, and even how planets like ours form and survive. Suddenly, magnetism, often the forgotten force, was front and center. And Voyager, this relic of the 70s, had become the only witness to a galactic ballet playing out on scales we never dreamed of measuring. These twisted fields might be scars left behind by ancient stellar deaths, or perhaps trails etched by something even more massive. Shortly after crossing into interstellar space, Voyager recorded something terrifyingly abrupt, a sharp spike in high-energy particles. These weren't random. They were cosmic rays, charged particles moving at near-light speed, likely accelerated by distant black holes and supernova remnants. And they were bombarding the spacecraft at rates far beyond anything measured inside the solar system. But more disturbing than the radiation itself were the patterns. These cosmic rays weren't arriving uniformly. They followed paths, corridors, highways. Like weather systems in deep space, they flowed along pressure gradients that hinted at a larger skeletal structure, perhaps the very bones of our galaxy. Some theorists now believe Voyager is mapping these gradients in real time, revealing radiation belts and particle flow routes that extend far beyond our heliosphere. It's as if Voyager stumbled upon an interstellar bloodstream with cosmic particles as its plasma. These aren't just wild forces of space. They are clues to a system, a map. And for the first time, we're getting a glimpse of how vast regions of the Milky Way connect through fields we can't see, but Voyager can feel. What Voyager has encountered is not a vacuum. It's a sea, a swirling, layered, dynamic ocean made of dust, plasma, and magnetic fields. NASA scientists describe it as moving through invisible fog, filled with currents and weather patterns. Every few months, Voyager enters a new cloudlet, a pocket of interstellar medium where density, pressure, and temperature shift dramatically. These aren't uniform changes. They're abrupt, defined. As though the space between stars is partitioned into invisible zones, each with its own identity. Voyager has even detected plasma wave oscillations, a constant hum that suggests the space beyond the heliosphere is vibrating with life, not biological life, but energetic motion. Some researchers now refer to this as interstellar weather, complete with fronts, eddies, and boundaries. These structures can affect Earth. As the solar system moves through the galaxy at over 450,000 miles per hour, we drift through these zones, and with each new environment, the cosmic radiation that reaches our planet changes. Over millennia, this could subtly influence everything from our climate to our DNA. Voyager isn't just a space probe, it's a weather station in the ocean between the stars, revealing that the space beyond our sun isn't still, it's breathing. For decades, scientists believed that the heliosheath, the outermost layer of the sun's protective bubble, was a slow, gradual transition between solar and interstellar environments. But what Voyager 1 has revealed suggests something far more violent. As it passed through this chaotic zone, its instruments captured sharp variations in plasma flow, particle density, and directional magnetic shifts that no model had predicted. It wasn't a gentle crossing. It was a rupture. The heliosheath appeared to fold in on itself, like a collapsing wave slamming against an unseen reef. Some experts believe this collapse may be caused by interstellar shockwaves, remnants of nearby supernovae, that periodically crash into the sun's outer defenses, warping the heliosphere in real time. Others propose a more unsettling theory, that this boundary isn't passive at all, but reactive, shifting its form depending on what's on the other side. In either case, Voyager didn't slip through a membrane. It was tossed through a torn rift in our system's outermost barrier. And what lay beyond was not empty space. It was structured turbulence, a layered storm of electromagnetic violence that reshaped the very concept of borders in space. Shortly after passing into interstellar space, engineers noticed something disturbing in Voyager's transmissions. Several instruments began returning values that didn't make sense. Plasma sensors indicated impossible pressures. The magnetometer reported a field strength that contradicted previous trends, and the cosmic ray detector began showing rhythms, regular pulses that couldn't be explained by any known particle source. At first, NASA suspected internal errors, decaying circuitry, radiation damage, or algorithmic drift. But then something extraordinary happened. The readings aligned across systems. Data from entirely different instruments began to sync, forming wave-like harmonics across the signal spectrum. This was not noise, it was resonance, as if Voyager had moved into a region where background frequencies were orchestrated, not random, but patterned. The team at JPL ran Fourier analyses across weeks of data and found repeating peaks spaced at consistent intervals, suggesting Voyager had passed into a region of deep space harmonic order. The shock wasn't just that the data made sense. It was that the universe seemed to be organizing itself around the probe, or perhaps that something out there was observing it and responding. Among the strangest discoveries was what Voyager didn't detect. During a quiet period in June, Voyager transmitted what initially looked like silence, a complete drop in plasma oscillations, cosmic ray impacts, and magnetic field variation. But when NASA's deep analysis team applied signal isolation, they found something buried inside the stillness, an echo, a reflected waveform that mirrored Voyager's transmission but delayed by milliseconds, as though something had bounced it back. This wasn't a technical glitch. The shape of the waveform carried a distortion unique to the interstellar medium, yet it was reversed, an imprint, not a reflection. That led some to speculate Voyager had sent a signal into a zone where something, possibly a structured boundary or even a non-natural phenomenon, responded. Not by creating new data, but by canceling it out. It was as if the void was trying to erase its presence, folding Voyager's signal back on itself. A null echo, a silencing, But that silence was intentional, and within it, the unmistakable signature of a system reacting to intrusion. What Voyager has been quietly assembling, over millions of data points and decades of travel, is more than a report. It's a map, not of stars or planets, but of cosmic conditions, the fluid topography of space itself. Scientists are now using Voyager's path to construct a real-time, three-dimensional pressure and plasma field model of the interstellar environment. What they've discovered is shocking. Space is layered. Regions of high-density cosmic rays flow like rivers. Pockets of magnetically shielded voids resemble lagoons, and invisible walls, transition zones between different galactic domains, appear to move, shift, and sometimes vanish entirely. But more frightening is that Voyager's map shows patterns too precise to be natural. Routes of least resistance that align with specific angles, arcs, and harmonic signatures. It suggests a geometry behind chaos, a blueprint beneath the noise. And if that's true, then Voyager hasn't just left the solar system. It has entered a network, one we never knew existed, one we were never meant to navigate. And now, we can't look away. When Voyager 1 launched in 1977, we believed we were sending a machine into emptiness, a slow fall into silence. But what it found on the other side of the heliosphere wasn't silence at all. It was structure. It was pattern. It was resistance. And now, for the first time in human history, we are beginning to understand that the space beyond our solar system is not a void. It's a realm. A domain with texture, temperature, magnetic skeletons, and quantum shadows that twist through fields we were never meant to cross. Voyager didn't just survive its passage into interstellar space. It shattered the illusion that there was nothing waiting beyond. Every signal it sends, every spike, every gap, it all tells the same story. We've crossed a threshold. We are no longer observers from within the cradle. We are trespassers in a region that remembers, where echoes bounce back with answers we never formulated, where magnetism forms corridors through the dark, where silence is not the absence of sound, but the presence of something choosing not to speak. This isn't just science, it's a new language, a new map, and Voyager 1 is the first pen to write it. But the question remains, if we've finally reached the other side, then who or what has been waiting there all along? Do you think Voyager 1 has entered a natural frontier, or has it crossed into something designed? Let us know what you believe in the comments. And if you want to keep exploring the mysteries NASA won't talk about, subscribe, tap the bell, and share this video with someone who still thinks space is just stars and silence. Because Voyager 1 didn't just reach the other side, it showed us we were never alone in the first place.